Morning, CSEC students. Welcome to another live CSEC math class. This morning, we are doing a matrix algebra. And we have so far in our live classes, we have looked at addition of matrices, we have looked at subtraction, we've looked at scalar multiplication. We have looked at the inverse of a matrix. We've looked at solving matrices solving simultaneous equations using matrices. So we've done pretty much all the subtopics. So now we're looking at matrix algebra. And once you hear algebra, you know that it's going to involve variables. That's what algebra is all about, right? It's going to involve variables. So you're going to see some X's and Y's and N's and A's and B's and whatever. So you're basically going to follow the same principles that you would follow whether you're given an addition, subtraction, scalar multiplication, product of two 2x4 matrices. Same principles you would follow. Just that you're working with variables. So in the solution, you're going to be finding the value of the variables. So what you usually would end up doing is equating two matrices, making one matrix equal to another, and then you would see the corresponding terms. Which term in one matrix corresponds with the variable in the other matrix? And by correspond, I mean which one is at the same corner as the other one. That's basically what we mean, right? Which one line up with the other one. So let's get into it. We're going to work some examples, just a few examples. So we have, given that, I'm going to write out the problem. Given that, so we have x, 3, -6, y. So that's our matrix. And this is the other 2x2 matrix, 5, -7, 3, 8. So this is equal to 24, A, B, 106. So given that the product of these two is equal to this, we were asked to calculate. So we're asked to calculate the values of so we need to find x, y, a, and b, 4 variables. So the 4 variables that are shown here, we need to find the variables. All right. So what we're going to do then is find the product of this. Use the same principles for working out the product of two 2x2 matrices. Same principle. We'll find the product of them and we're going to equate them to the other matrix at the end here. We're going to see what lines up with the A and the B and how we can find the X and the Y. So let's do that multiplication first then. So we're multiplying this matrix by this one. So we know it's row by column. Remember, row by column. So it's x times 5, which is 5x, and 3 times 3, which is 9. So that's 5x plus 9. Then x times negative 7, which is negative 7x, and 3 times 8, which is 24. So that's a positive 24. So that's the first set. So remember, it's row by column, row by column. So x times 5, 3 times 3, x times negative 7, 3 times 8. So we finish with these two, go to the bottom ones now. So it's negative 6 times 5, which is negative 30. And y times 3, which is positive 3y. And negative 6 times negative 7, which is a positive 42. And y times 8, which is a positive 8y. All right. And we're to make this now equal to this. Because remember, they said the product of these two is equal to this matrix. So make it equal to. So that's 24 A B 106. So we need to find the values of the variables. So let's equate them. So 5x plus 9 is in this corner, 24 is in that corner. So 5x plus 9 is equal to 24. So if 5x plus 9 is equal to 24, then 5x is equal to 24 minus 9, which is 15. So 5x is equal to 15. Therefore, we know that x is equal to 15 divided by 5, which is 3. So we have solved x. We have solved for x. X is 3. All right, so now let's see which other variable. So if we know that x is 3, we can plug x here and make this equal to a, because this is in the same corner as a. So now that we know x is 3, using this expression, so negative 7 times 3 plus 24 is equal to a. So that negative 21 plus 24 is equal to a. Therefore, a is 3 also. So a is also 3. X is 3, a is 3. So let's find out. We have two variables left. So we have y and b. So since negative 30 or 42 plus 8y gives 106. So we can find y using this. So 42 plus 8y is 106. So 8y is equal to 106 minus 42, which is 64. So 8y is 64. So y then would be equal to 64 divided by 8, which is 8. So y is equal to 8. So we have found 3 of the variables so far. So since y is equal to 8, we can find y. This is equal to b. So we can find b now, substituting 8 where y is. So we're going to have negative 30 plus 3y is equal to b. So negative 30 plus 3y is equal to b. And since we just found that y is 8, so negative 30 plus 3 times 8 is equal to b, and 3 8s are 24. So negative 30 plus 24 is equal to b. That means b is negative 6. All right. So give me some feedback. Give me some feedback on the first example that we worked. Do you understand? I'm going to go over it from the top. All right, so from the top, let's go. So let's go back to the first slide. So the original thing that we were given, two 2x2 matrices, just that one of them had variables in it. We had an x and a y. And we're told that given that the first matrix with x, 3, negative 6y, the product of that and the other matrix, 5, negative 7, 3, 8, the product of these two matrices. So when we multiply these two matrices, we're going to end up with this matrix. They gave us two of the values already, which we got. We got those two values. And they want the other two. So we have to work out the multiplication, the product of these two, and equate and see which numbers line up in these two corners here. So when we expand matrices, we multiply rows by columns, rows by columns. So this row times that column, and that row times that column. And then this row times this column, this row times this column. So it's x times 5, which is 5x, 3 times 3, which is 9, x times negative 7, which is negative 7x, and 3 times 8, which is 24, negative 6 times 5, which is negative 30, y times 3, which is 3y, negative 6 times negative 7, which is positive 42, y times 8, which is 8y. And remember, we are told that this product is equal to this matrix. So we're equating them. So 5x plus 9 is equal to 24. Negative 7x plus 24 is equal to A. Negative 30 plus 3y is equal to B. 42 plus 8y is equal to 106. And we'll just use them one by one and find the unknowns. So this is how the algebra comes in now. So we're solving equations. We're solving linear equations. 5x plus 9 is equal to 24. Therefore, 5x is equal to 15. And 15 divided by 5 is 3, and so on. So down here is just basic algebra, solving algebraic equations. And this is the last one. So let's go on now. We're going to go on now to the second one. All right. Okay, so Imani is saying, Miss, I understand completely now. And Ngozi says, I understand a lot more. All right, so let's go on to number 2. I'm happy to hear that you understand now. So we have 2 more examples to work. So number 2 says, given that A is equal to, so matrix A is equal to, all right, excuse me 1 second. All right, so let's continue. So we have, given that A is 3, 0, 0, 5, and B is X, Y, N, P. So, and also, so something else, and AB, this mouse is doing all kind of antics this morning. AB is equal to A plus 6B. AB is equal to A plus 6B. So we're to calculate the values of this mouse is not working with me this morning. Calculate the values of X and P. All right, so they just want what is X and what is P. So this is matrix A, 3, 0, 0, 5, and B, X, Y, and P. They're saying the product of the 2 matrices is equal to A plus 6B. So first we need to find the product, and then we need to find A plus 6B, the sum of these, and equate them, make them equal to each other, and then see what lines up with X and what lines up with P. All right, so let's multiply them and see what happens. Okay, so let's find the product. So it would be A times B. So A is 3, 0, 0, 5. And B is X, Y, N, P. So let's multiply them. So 3 times X, that's 3X. And 0 times N, that's 0. So that's 3X still, because adding 0 is going to give you the same thing. And then 3 times Y, that's 3Y. And 0 times P is 0 as well. 0 times N is 0. And 0 times X is 0. And then we're going to have 5N. So we can just write, we don't have to put the 0 then. So we can just put the 5N. 5 times N, that's 5N. And then 0 times y is 0, and 5 times p is 5p. So this is the product that we got. And we are told that this product is equal to a plus 6b. So let's write back a. So a is 3005. And 6b, so plus 6 times b. And b just had x, y, n, and p. So this is scalar multiplication happening here. So we just need to multiply each of these terms by the 6. So it will be 3005 plus 6 times each of those would give 6x, 6y, 6n, and 6p. So they want us to find, all right, so when we add these, when we add them, we get 3 plus 6x and then 0 plus 6y, which is 6y, and 0 plus 6n, which is 6n, and 5 plus 6p. 5 plus 6p. And so this product here is equal to this sum there. So let's equate them now. So we had 3x, 3y, 5n, and 5p. And they want us to find the value of x and p. So we just need to concern ourselves with this and this. So 3x is equal to 3 plus 6x. 5p is equal to 5 plus 6p. So let's solve the x first. So 3x is equal to 3 plus 6x. So therefore 3x minus 6x is equal to 3. Negative 3x is equal to 3. So x is negative 3 over 3. So x is negative 1. And 5p is equal to 5 plus 6p. So it's a similar setup here. So 5p minus 6p is equal to 6. So negative p is equal to 6. Therefore, p is equal to negative 6. So x is negative 1. P is negative 6. All right. So how is that one? Give me some feedback on that one. And we have one more to go. We have one more example to go. Okay, so Imani says, yes, miss, I got it, which is great. That's awesome. Hopefully, the rest of you understand it now. So let's just work number 3. Let's put it to the test even further and see if we understand number 3. So number 3 says A is equal to 10, 3, 1, 0. And B is equal to 5, 7, -5, -3. So the first thing they want us to do is to calculate the product AB. That's what they want, the product. So we know we're going to multiply row by column, row by column. So it's 10 times 5. So the product AB, so 10 times 5 and 3 times -5. So 10 times 5, 3 times -5. And then 10 times 7, 3 times -3. So 10 times 7, 3 times -3. Going to the bottom now, 1 times 5, 0 times -5. So 1 times 5, 0 times -5. And then 1 times 7, 0 times -3. So 1 times 7, 0 times -3. And this is supposed to be a 7. So now we just need to simplify these. So 10 times 5, that's 50. 3 times -5 is -15. 10 times 7 is 70. 3 times -3 is -9. 1 times 5 is 5. 0 times -5 is 0. 1 times 7 is 7. 0 times -3 is 0. So we're going to end up with 35, 61. So 50 minus 15, that's 35. 70 minus 9, that's 61. 5 minus 0 is 5. 7 minus 0 is 7. So this is what we end up with. That is the product of the 2 by 2 matrices. So now they want us to do something else. So they're saying, next part of it says, part B, if C is equal to x -4, 5, y, and 3a, so 3a plus c is equal to ab, the product, which we just found. We just found the product, so we're going to put that answer here and work this out, and they want us to find x and y, the variables. Remember, this is how algebra come into it, right? We have variables to find. So find x and y. So we already worked out AB. So it's just a matter of plugging in that answer here. We're ready for it. We already worked out what AB was, and that was 35, 61, 5, 7. So let's find out 3a plus c, and then plug in this that we just found in part A and see if we can equate them to find x and y. So the 3a would be 3 times 3 5. Sorry, 10, 3, 1, 0. That was A originally. And C is this. So that plus C. So plus X negative 4, 5Y. And they're saying it's equal to the product. We just found the product, which was 35, 61, 5, 7. All right, so let's work out what this is here. So 3 times 10, that's 30. And 3 3s 9. And 3 1s 3. 3 times 0 is 0. So that's a scalar multiplication. And we're going to add the x. So we're going to equate the ones that are in the same corner, we're going to add them. So this part of it is going to give us 30. So 30 plus x. 30 plus x. And then 9 minus 4. So 9 minus 4, which is 5. So this is 5. And 3 plus 5, so that is 8, and 0 plus y. All right, so we need to equate them with the product that we just found. They only want us to find x and y. So 30 plus x will be equal to 35. And y, already we see y is equal to 7. So 30 plus x equal 35. Y is equal to 7. So we already know y is 7. So x is equal to 35 minus 30. So x is equal to 5. All right. So x is equal to 5. All right, so that's it. That's it for the matrix algebra. So we're basically just doing the same principles that we do for matrix addition, matrix subtraction, scalar multiplication, 2 by 2 product. Even if they get into the inverse and the, finding the determinant, anything like that, work it the same way, just use the variables wherever they are given. And then ultimately you're going to be asked to equate one matrix with the other and see which number is in the same corner as the letter. Or maybe it's an expression that's in the corner. Just make it equal to the number that's in the corresponding corner, and you have created an equation that you're going to solve. Those are the basic principles of matrix algebra.